Okay, so yesterday I talked about the factorial being one way of figuring out different arrangements. So just to remind you, yesterday we talked about a concert that if you have 4 groups and you're trying to arrange who's going to play first, second, third, all you do is just multiply the different possibilities. So there's 4 groups to pick from at the beginning, then 3, then 2, and then 1. So I talked about something like this, which is called the factorial. It's just a quicker way to multiply numbers. Today we're going to take this to the next step, which is something like this. Okay, so keep in mind what we did. There are 13 players on a baseball team. Okay, you need to choose a batting order of having 9 players. How many different batting orders can you form? So it starts off being the same thing as we did yesterday. How many choices do we have for batter 1? 13. How many do we have for batter 2? And then 11. Okay, fill this in. And then 10 people to pick from. So technically, this is not very different than what we talked about yesterday. You just multiply. However, would this be the same as doing 13 factorial? No, because what's happening? Like, what's missing? What are we not including? The 4 times 3 times 2 times 1. How could we write this? How could I write the 4 times 3 times 2 times 1? What is that really? It's really 4 factorial, right? So that is missing from the calculations. So in order to be able to do these problems, there's a formula that's called permutations formula. That's the NPR on the calculator that I just showed you. And here is the calculations. 13 all the way up to 5 is really like this. 13 factorial, which what we have right here. And then you end up dividing by 4 factorial because what's going to happen with each of these? They're going to cancel. So in the end, it ends up being like this. How many people do we have to choose from? 13 players. How many players are going to be left over and not playing? 4, because it's 13 players minus the 9 that we've selected. Okay? So the formula, the permutations formula, the special notation looks like this, 13P9. And it stands for 13 people, and then you do the permutations arrangement for 9 of them. Okay? And it works out 13 divided by 13 minus 9. The number of possible permutations of, this should be of R items are taken from N items is like this, NPR, okay? N permutations R, N factorial over N minus R. And the N minus R, you're simply figuring out, I'm choosing out of 13, I'm choosing 9, how many do I have left over? That's what this number stands for. One way to do it is, of course, the long way, kind of like this, where you show all of your calculations and you show what cancels out. It's not that difficult. Or you grab your calculator. Let's actually type this in. So on your calculator, you guys, the bigger ones, or you will have to type 13 first, and then go to math, probability, number 2. And yours is going to look a little different than mine. You're going to have a bigger 13. And then we are picking 9. So what it looks like, it's 13P9. Hit enter. What do you guys get? 2,500,000. No, never mind. Even more. What am I saying? 259,459,200. That's why baseball people make so much money. I mean, all the coaches. Yes, can I see your calculator? Let me show it on the Elmo. Because on the big calculator, it looks completely different. So you would, in this calculator, you would have to press 13, and then math, go over to probability, number 2, and then 9. So my calculator just has a different notation. It looks smaller, but it's the same thing. So it means take 13 players, select 9 of them. How many different arrangements do you have? 259 million, blah, 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 blah. That's a lot. That's a lot of different permutations. Does this make sense? Okay, so whenever you have a permutation problem, you're welcome to just use your calculator. Thank you. Or let's try one and I'll show you both ways. Example 4 on the next page. You and 19 of your friends. So when you're talking about you and 19 friends, how many people is that? 20. Decide to form an internet marketing consulting firm. The group needs to choose 3 officers: CEO, operating manager, and a treasurer. So how many people are we going to be choosing? 3. In how many different ways can those offices be filled? So N is 20, because you're picking out of 20. You're picking 3 spots. So the one way to write this down would be 20, P, and 3. So the 20 and the 3 are kind of lower down here. And why don't you guys type this into your calculator, see what you get. Use that probability button that I showed you. Well, because you're gone, I'll check later. Next time, go to the bathroom during announcements. Did you do it? Let me give you a sticker. What did you guys get? Did you get 6,840? There we go. Now, I want to show you how this is done. Let's say, Kevin, stop talking. Let's say you actually don't figure this out. So what's the formula? Like, if you don't have a calculator, you can still do it. What's the formula? N factorial over n minus r. So you would do 20 factorial over 20 minus 3 factorial. So it's 20 factorial on the top. What is it on the bottom? 17 factorial. What ends up really canceling now that you've seen factorials for a little bit? Kevin, which ones are going to cancel out? Or which numbers are going to be left over? Were you here yesterday when we did the factorials or no? Yeah. So like what's going to be on the top? What does this stand for?
20, 19, 18,
and that's it. That's exactly what I'm looking for. Because everything else cancels out. Can you guys multiply these 3 numbers for me? Jacob, where's your calculator? Reminder, Ricky, call him today, text him, Anthony, Snapchat him, or whatever. Send him a postcard, bring it, because you're going to be confused. So what's 20 times 19 times 18? It's the same thing. Technically, you guys have 2 ways to do this problem. You could just use your calculator with 20p3, or you can use the formula if you remember it. Or another way, like this is what we used to do in the beginning. If you're choosing 3 spots, how many people do you have to choose for the first office? No, out of how many are we picking? 20. Once you've picked the officer, how many people do you have to pick from? And then after that? But this is the simple way because this is small. I would not advise you just doing it this way if the numbers get large. Okay? So you have 3 ways of doing these problems. Example 4b. A corporation has 7 members on its board of directors. In how many different ways can it elect the president, vice president, secretary, and treasurer? N is 7. So out of 7 people, we are going to be selecting 4. So why don't you guys do 7p4? Let's just do calculator for this one. Type this in. I think your phone, if you put it sideways, you might have this. I don't know. Okay, did you guys get 840? Okay. Yes? Yeah. Let's do the next one. Example 5. You are working for the Sitcom Television Network. Your assignment is to set up a television schedule for Monday evening, 7 to 10 p.m. You need to schedule a show in each of the 6 30-minute time blocks. So it's 6 of 30 minutes, 30 minutes, 30 minutes, 30 minutes show, beginning with 7 to 7:30 and ending with 9:30 till 10. You can select from among the following situation comedies. Why don't you guys count how many shows we have? No, count again. It is 13 shows. So we are going to be selecting out of 13 shows, how many different schedules can be arranged? So it's 13P. How many spots do we have to fill? In each of the 6 30-minute time blocks. So out of these 13 shows, you're going to be picking 6 of them. Figure out what's 13P6. Juliana, can you have Kevin try this on your calculator so he learns it? All right, make sure you guys got 1,235,520. Are we okay with this? Are you getting this? Does this make sense? I'm just going to continue to finish up the notes because the rest is kind of easy. Example 5, how many different programming schedules can be arranged by choosing 5 out of a collection of 9? So what's my N? 9, and what's R? 5. So we're going to write 9PR, I meant 5. 9P5, which is 15,120. So whenever you're choosing some amount out of something bigger, you're going to be using permutations, and this is where the order is going to matter, okay? Now, what about if permutations of duplicate items? What that means is if something is repeating. Here's one example. The number of permutations of the letters in the word set is 3 factorial, which is 6, because that means 3 times 2 times 1, which is 6. If you're rearranging the letters. In how many ways can you rearrange this? Well, S-E-T is the original. What could you do? You could switch T and E. So it's S-T-E, E-S-T, E-T-S, T-S, T-S-E. Those are the only possible ways to rearrange it. Does that make sense? So there's 6 of them. However, let's try to rearrange the letters on the next page in the word Anna, A-N-A. Can you guys take a second and show me into how many ways can you rearrange these? So the first one is A and N. That stands. So how many are you getting? 3, right? Because we could put like A and A first and then N. Or I could put N first and then A and A. Now, if I end up switching this A with this A, will the arrangement look any different? No. So for this case, we only have 3. So what that means, if you have repeating letters or if you have repeating items, there's going to be less arrangements because they're going to look exactly the same. So permutations of duplicate items looks like this. The number of permutations of N items, where P is identical, Q items are identical, R, and so on and so on and so forth. What you end up doing is you take the total and you divide by whatever is repeating. So here's an example. In how many ways, well, so this one was, we had 3 letters for the word Anna, so that's 3 times 2 times 1. The letter A was repeating. It happened twice, so we divide by 2 times 1. So this and this and this cancels. That's how I know it's only 3 arrangements. here's how you guys will have to do it. In how many distinct ways can the letters of the word Mississippi be arranged? First of all, how many letters is that in total? There's 11 letters. Okay, so N is going to be 11. But now, what is repeating? So count, how many I's do we have? How many I? How many? 1, 2, 3, 4. How many S? 4. And we also have P. How often does P happen? 2. The ones that happen only once, you don't need to do anything with. So what this formula tells you, how many ways are there to rearrange this? Take the N, whatever your total is, so 11 factorial, and divide it by the repeating numbers, by the repeating letters. So there's 4 I's, so it's 4 factorial, 4 S, so 4 factorial again, and then 2 factorial. And this is where you just use your calculator. You can use the alpha Y, or if you don't have it, you will use division. But then you would have to do parentheses on the bottom. So here, I'm going to do alpha Y, put 11 factorial. And then on the bottom, you don't even have to put in times because the calculator is going to know. So it's 4 factorial, another 4 factorial, 2 factorial. Make sure you guys get the following number. Please try it on your calculator and make sure you get 34,650. Okay? All right, try example 6B. Why don't you count the letters and count the repeating items? All right, check that you got 420. What I would like you to do next is open up your practice packet. Those of you who did not do the homework, I'm going to ask that you finish 1 through 6 for homework. Try it again today. But now you are ready to start, like finish this up right here, 7, 8, 9, and you could do number 10, 11, 12 using your calculator. And then page 4 is your actual homework, which we do have plenty of time for you guys to finish maybe here in class. 13 all the way up to 18, that's when you would use the NPR formula using your calculator.